Perfect. All right. Hello, everyone. My name is Samantha Rasmussen. I'm a junior studying computer science here at Indiana University. And on behalf of my co-authors, I'm excited to present to you our topic of payload drones in ACI, a drone navigation system prototype. First and foremost, I wanted to share our motivations for choosing this topic. Unmanned aircraft systems, or more commonly known as like drones, have become much more prevalent in recent years and are being actively researched for their potential application for the promotion of animal well-being. And more specifically, researchers have been focused on how drone interactions affect both humans and animals and how drones can be used to understand animals better. And to be applicable in captive care environments, the existing research needs to focus on working with animals as the sole participant and the constraints in the structure of the enclosure and the animal care staff. In this work, our focus is on the potential of a payload drone delivery system that has the capacity to deliver food or other enrichment object rewards by drones to animals in captive care in order to motivate both foraging behaviors and the use of their structural enrichment in their like personal environments. And I just want to talk a little first about where this can be like the most effective. And in the case of wildlife rehabilitation, where reintroduction to the wild is the goal, the least amount of contact with humans could be helpful for successful rehabilitation. And in these cases, a drone system that delivers food could limit these interactions and enable success in that transition. I don't know if it's going. Oh, there it goes. And in the case of zoos, where some include functional naturalism in their design of enclosures, which may include tall structures seen on this slide or like platforms where zoo care staff may have difficult time like safely accessing, our proposed system could potentially alleviate these issues by using the system to deliver the rewards to the animals without requiring the zoo care staff to do it themselves. And this provides an efficient way to encourage the animal's natural behavior and promote their health, while also taking advantage of the structural enrichment that like resembles the animal's natural habitat. And now to look at like the proposed system we created, our prototype includes the first phase of an aerial system designed to place food and objects in an outdoor enclosure. We intended to create a system using an Android app and a drone to locate specific colored squares in a designated area autonomously. And then first and foremost, the design of our app kept the animal care staff and their knowledge or lack of knowledge on drone piloting at the forefront. And here the app figure can be seen. And while it's at its specified home area, it has the option of 3 destination buttons, an emergency land button, and the ability to view the live feed of the drone. And that's on the left side. And then on the right side, that will be when it is already in the phase of moving on to a platform. And that includes the emergency land, the option of home, and the live feed. The most important aspect of the app we decided on would be the color destination markers, which would accurately represent the specified color squares. And then secondary was the return to home option on the app. In the potential implementation, the user has the option to choose the destination button, which coincides with a colored square, and then the food stored on the drone would then be placed at the colored square. And in any of the phases, the emergency land button will always be able to be pressed. And we believe this allows like the most simplest like interface for the care staff to operate. And in our research, we utilized a DJI Phantom 3 standard drone, which includes a camera below its main components, which records at an image ratio of 1280 by 720 at 30 frames per second, which just allows for optimized processing. And in order to successfully link the drone and app so that they can communicate the exact same drone state, we used a deterministic finite automation. And using the stages shown, the app screen would simply display the options depending on the current state of the drone. And for the performances of the commands themselves and to identify the destination colored squares, we utilized open color vision on the Android app. And the open color vision functions we used process images to find contours and then process perspective transformation in order to identify the rectangular shape of the colored square. The color is then checked to see if it is the correct destination square. And then once that square is located, the second phase for the drone system initiates, which begins with the drone maximizing the size of the square by moving closer to the target and centering the square in its own image. And then using onboard sensors, it will lower itself by 10 meters. And once it has centered on the image, this second phase will repeat until the drone is 2 meters above the appropriate destination square target. And that would be when the future system would perform the payload drop of the enrichment object or food reward for the animal. And then the user would press the return home button and the drone would repeat this phase 2 process to find its way back to its original location. And at any time during the phase of the system, the user can send a command for the drone to return home by pressing that specific button. And yeah, so to continue, I want to discuss the testing of our, fit lets me go there. There it goes. And we designed an evaluation set for our testing of payload drones. And we just wanted to make our tests applicable for future iterations and implementations. And past work in the drone testing field has been done with hardware and environmental specifications in mind, which structured our own testing based on the possibility of different environmental constraints. Currently, our payload drone system does not even consider the possibility of an animal being present, as the aim of our evaluation is to simply track the efficacy and accuracy of the drone task completion. This would allow the system to be thoroughly reviewed and evaluated so we know if there are any challenges yet thought of before including an animal participant. We conducted this testing through task metrics recorded over repeated testing, which would allow us to see the possible constraints of the system depending on the deployment context, which, as we know, can greatly vary. And additionally, the proposed evaluations are split into a general purpose set of 7, which ensure all potential points are tested. For example, if a project has 1 home pad and 2 target drop points, the test should include 4 tests, which would be home destination to target 1, and then home destination to target 2, and then target 1 to home destination, and then target 2 to home destination. And for the testing and timing of our system, we begin once the command is sent to the drone, such as pushing the button on the app. And then the timing includes the takeoff and the possibility of landing as well as transfer time. However, the timing does not count when the drone is successfully hovering over its target or if it's completed its landing. And in the event there is a participant involved, we include participant avoidance to ensure that a participant cannot come into contact with the drone. And this includes movements such as jumping, climbing, running, as well as flying if the participants have that capability. And furthermore, we wanted to ensure that the delivery of the physical reward, such as food, had a steady drop accuracy and percentage. So we tested by measuring the distance of the closest point of the object to the center point, and then the total amount of food or objects that are successfully dropped is measured. And then this testing would be done for all potential rewards that are wanted to be used. And these 2 tests would be then replicated with the additional consideration for participant avoidance in the event a participant would be involved. We also wanted to ensure that the emergency land commands response time is considered. So testing should involve the timing to make sure that there are no delays in any movement paths and states of the drone. And then in cases with participants, testing should emphasize their safety and the measuring of any potential known impacts. And then in these cases, there must be specific testing based on the species of the animal. And additionally, with any technology, there must be considerations for its capabilities and the concerns with its security. So we considered potential issues that may come up in a payload drone system and possible solutions. And as we know, since drones have the ability to move freely through a 3D space, measures should be taken to limit that drone's ability. And there have been previously proposed solutions, which include geofencing as a possible method, which has the ability to restrict where a drone can fly based off its current GPS coordinates. However, in a smaller area like a zoo enclosure, using Bluetooth or Wi-Fi nodes have been proposed previously as well, and that can outline a potential area to make a custom geofence. We also considered radio frequency identification applications as another proposed solution, as it could result in energy saving. And for possible security concerns of these drone and apps, Drones are very susceptible to security risks, and working in a public area like a rehabilitation center, for example, or zoos, they can increase those risks. So for this system, monitoring and following like local laws and regulations are really important to keep in mind if recording using their drone or using Wi-Fi in their area. And this payload drone system has the possibility of improving quality of life for a variety of animal species. So applying this technology with a great amount of thought is important for these considerations. And now I'm going to look at additional considerations for ensuring that the payload drone system has every opportunity to succeed, especially in the animal context. An animal-centric approach can be applied in the beginning of creating the system to assure that it is approached from a non-human perspective. The ACI community has done a lot of work on a variety of animal-centric methods for system design. And drones have the potential to be a source of negative stimuli for the potential quick movements and sounds they make that humans may not pick up. So interaction tests must be performed when animal participants are involved, and having a thorough understanding of the animal's perception is important. In addition, additionally, not only is the potential active participant to be kept in mind, but also the animals surrounding those enclosures. Because potentially a loud and quick system like a drone could result in a stress response from those animals as well, which means that researchers must work with zoo or similar care staff to ensure that there are no additional burdens being placed on any animals that are potentially involved. And this can not only like minimize the negative interactions between the system and the participant, but maximize the positive like potential it has. And in a rehabilitation context, unlike a zoo, a payload drone delivery system can take a small burden off the care staff by deploying feeding opportunities while also limiting the interaction with humans. However, the capabilities of the care staff and the organizations have to be examined, as they may not have the funds for the equipment required for a drone system, or the staff could have barriers with technology use if there is no prior experience there. And of course, steps can be taken to acquire funding and train care staff so that the systems can be more accessible. And in concluding this presentation, I want to kind of reiterate the potential that a drone system like our proposed research describes can have in supporting animal health and well-being. Drones have the capability of limiting human interaction as well as increasing space utilization, which has the potential to create a positive impact on the visitors, but more importantly, the animals themselves. And thank you very much for your attention and time. And if you have any questions, I or Cassie would be happy to answer them now.